So, ladies and gentlemen, I want to welcome all of you to panel data econometrics, longitudinal data. Now, before you can appreciate what a panel data is, we want to recapitulate what cross-sectional data is. What is a cross-sectional data? A cross-sectional data set is a data set where you have many individuals. And please note the word individuals here can be cars, dogs, human beings, cities, countries, households, companies, trees, and several things. So the individuals here is not really about individual human beings, but several kinds of entities. When you observe these entities at a point in time, where that point in time can be in a day. So you can look at the nature of the stock market in a day, or you can look at the currency market or the crypto market in a single day. So in a single day, we have 24 hours. So within that 24 hours, every 1 hour, what's happening? Every 1 hour, what's happening? Every 1 hour, what's happening? And you can have different behaviors of different cryptos. And that is a cross-sectional. So the ordering doesn't matter. You can bring individual number 50 in front and take individual number 7 to the back. It can also be a year. For example, you can look at the different banks. So in this case, the banks are the individuals. And you can look at different banks in an industry. Let's say the number of banks are 30. You look at all these banks in a period, a single point in time, where this single point is a particular year. And then for each bank, you will have their return on asset, return on equity, expense, ratio. You can have total assets, deposit, total loans, and all that for each bank. So each of those variables are cross-sectional. So the entire data set is said to be cross-sectional if they are examined at a point in time. And that point in time can be days or hours or weeks or months or years. Please understand that. Now, and the variables could be many variables, but they are all examined at a point in time. And then you can have a single variable, okay? A single variable or many variables, many single variables, but they are examined over time. So if you take something like inflation alone, you can look at inflation in 1950, 51, 52, up to 2025. In this case, it's a single variable that you're looking at it over multiple time periods. In this case, the ordering, the way you arrange them matters, because you can't give inflationary value in 1950 and bring that forward and take inflationary value in 2024 and take that backward. You can't. Ordering chronologically matter. If you order them in a particular chronological order, that matters. That's different from longitudinal data. These are individual data sets that have both cross-sectional and time series facilities. Okay, so they contain observations on multiple individuals across multiple time periods. Watch it. Multiple I over multiple T. Multiple I over multiple T. So you can look at banks across different time, not the previous one when you were looking at banks at a time. By looking at banks profit, banks losses, banks assets, banks loans, all of it for different banks across different times. For different banks across different time. And this is said to be one of the powerful data sets that one can have. Okay. Now, this panel data, because they are actually very powerful, because they are very useful, what we are going to do is to understand them very well. One of the panel data set can be balanced, another can be unbalanced. Who can tell me the difference? Who can tell me the difference between the balanced and unbalanced panel? On top of your head. Someone.
Yes, please. So I think with the balance, the population remains the same throughout the period under analysis, but with
What is
unbalanced,
population here?
The individuals, as you noted. So the individuals
Can we
being
talk about
analyzed.
sample for now?
Okay, so the sample remains the same over the period being analyzed, but with the unbalance, the sample changes from time to time, or the sample varies over the period under analysis.
Give me a practical example.
So, for example, if you are doing a study, let me see.
You know, example is more efficacious than precept.
Yes, please.
Who can give an example to help him? Who can give an example? These days, I'm going to be calling you individually. You fail to answer, I fail you further. Yes, Francis.
Yeah, so Doc, a practical example would be we are looking at banks, but some banks started before others. So probably a bank was came into business in 2020, and another bank came into business probably in 2021. So when you observe their data over the period, you realize that
over what period?
Over maybe up to 2024.
From
2020 to 2024. You have some banks set up in 2020, some in 2021. So when you observe when you look at their data from the data from for the banks from 2020 to 2025, you have some starting from 2020 and some starting from 2021. So in that case, the data is not balanced.
Okay. Now when is it balanced?
It's balanced when we have ideally, if all the banks started at the same time, 2020, and they all ran and are in existence till 2025, then we can have data covering all their periods. But sometimes too, some data may not be available for certain periods, and it also can create unbalanced panel. But if we have data for all the various observations or the banks across the period that we are looking at, then the data will be balanced.
Okay. Good, excellent. That is exactly the way it is. So if you look at the one, both balanced and unbalanced data are good. And I'm going to look at examples why they are good, the reasons. Reason number one is that the larger the sample, the better. You are able to beat a problem called the curse of dimensionality. The curse of dimensionality is that situation where the number of independent variables in the regression are more than the sample size. So the sample size is now having more dimensions. And so there is that kind of complexity in the dimension. You know, for example, it's easy to draw a Cartesian plane, an XY graph, which is an easy thing to detect something. But even though life itself is in a complex polyhedra, when you want to draw a total polyhedra, say a hexagonal pyramid, it's going to be quite difficult to look at the multiple faces at the same time. So when you have more sample, you are able to handle that case of dimensionality. So larger number of observations will increase the sample size, which is good. And all problems that can come about as a result of using cross-sectional data will be handled. Multicollinearity is likely to be handled because multicollinearity occurs when two independent variables are correlated. But as you get more of the data, you will realize that their correlation would probably change because of the time, not because of anything, but because of the time. So that is one advantage. But it doesn't mean that because you have a lot of data, you're going to handle heterogeneity. There's still going to be heterogeneity. You will still have some of the, if it is firms, some of them will still be mining firms, some of them will still be services firms, some of them will still be agricultural firms. So there's still likely to be heterogeneity to handle. Second advantage, it will give you better information. You can look at trends and patterns. Okay? You're able to handle questions that normal cross-sectional or time series data cannot handle, especially when it has to do with multiple industries. Okay? So you have several industries within, and then you're also able to augment the sample size. You can look at the effect of something on something. You can have treatment, you can have controls, you can have dynamisms. And of course, you can make policies. You can look at before and after policies. For example, what is the situation before and after COVID? Would COVID have defined the way people behave online now? Anyway, let me just ask you, would you say that COVID has, quote unquote, significantly affected the way people behave online now? Would you say that?
Yes, sir.
Yes. Yes,
Under what
please.
circumstance?
Sir, I think before COVID-19, when it was most often work and home, people normally went to work, came back tired, and went to sleep. But during COVID-19, a lot more people sat home and started posting certain things online, which even after COVID, they are unable to stop. And so COVID seemed to have made people more interested in social media than before.
Okay, good. That's good. What else?
Doc, one aspect that has been noticed in the academia was people who have gone to do, say, their master's PhD online. Per the accreditation system, those people were not, quote unquote, accepted. But the world witnessing the COVID pandemic has brought the new norm of studying online and getting such certifications. And now our accreditation institutions are now accepting such certificates as fully rewarding. And also, studying has also been expanded to include online versions where people that are restricted by barriers of distance are now being brought together to share common goals and have meetings all over the world. Thank you very much.
Yeah, that's true. So and what has it done to costs?
From the working environment, it has reduced costs drastically. For example, myself staying all over Ahimensa, driving all from Ahimensa to Accra Central to work every day, burning gallons of fuel. Now I can sit at the comfort of my home and work 4 times at the house and go to the office at most. One a day a week, which has brought a lot of relief and comfort to us all. So, for cost of traveling,
How about me?
Dog, it has blessed you. Just that you may be to see the kids and your wife more frequently.
Of course, there's a disadvantage to it as well, which when we start talking about it, we can list them. But at least now, I'm still able to teach you from a distance, isn't it?
Oh, sure. And that the COVID has brought more good than harm. Though
Yeah.
a lot of death occur which we cannot replace, but the aftermath, we are seeing a new norm, a new world with a lot of innovation as well. Thank you.
Yeah. So that's panel for you. That's panel. We are able to see the impact of something on something. You're able to look at the impact of financial crisis, on performance, simply because we have a data before and data after. And so we can look at that to handle a lot of things. Panel data is very good. It can help you to make good predictions, because you're able to before you can do a prediction, you got to look in the past before you can predict the future. So you must have past data, use the past to predict the future. But what if there's nothing past? So cross-sectional is just one period. There's nothing to have in the past to be able to predict the future. You can also handle certain inferences like non-stationarity, measurement errors, dynamic panel data. You can use two-stage least squares, instrumental variable, labels approaches. You can use systems GMM, difference DMM, and several of these, in a panel analysis. In fact, even those that have limited dependent variable regression, like truncated regression, 2-bit regression, logit, probit, all of these kinds of regression, we can have their panel versions, which is really, really, really good. I mean, before we used to say that gender is male and female, isn't it? So yeah, but these days we don't talk about gender like that because of dynamism. The same person can. So now we put one rather as sex, and then we rather bring different kinds of facts. So all of these are examples of ways to handle panel data and to show how important panel data econometrics really is. So this is a panel data, a balanced panel. Nothing, everything, like Francis said, everything is filled. But if you compare it with this second one, you can see that where you have the NAN, those not availables clearly show that the data is not what? Balanced. You still have, 11 years. If you take number one, it still has 11 years, but the data is not balanced. Now, previously, we could not handle these. Previously, we couldn't handle it at all, where you need to have the other variable. But these days, you can have interpolation, to be able to fill the gap. That is here. We can use interpolation to fill the gap. Or we even have econometric models that can actually handle the work as it is, without being bothered about the gaps, the unbalancedness in the data set. Okay, now let's look at cross-sectional. Let's remind ourselves of cross-sectional data. You know this already. And I'm going to give you this cross-sectional data in the form of simple, exogenous variables. Okay. And I want you to consider them maybe even in the form of a matrix. So you have y equals to alpha plus beta x plus the ui. This is a cross-sectional data. Guys, who can tell me why this is a cross-sectional data? What gives you a clue here that this is a cross-sectional?
Hello, sir.
Yeah.
If it was time series, for example, there would have been this subscript of t indicating time. But in this case, it's not there, just I. The I stands for the firm or the entity you are talking about. So it is cross-sectional.
Very good. There's no question about that. Okay. What makes this one time series? Still you.
So it's time series because when you look at, for example, from the dependent variable yt, so the time, it is indicating time, and all of the other variables are at the right hand side. You also have the t indicating time.
Good. So if there is t, what does that mean also? Who can tell us? If there is t, what does that mean also? I need two examples. Who is following? If there is T, it also means what? You have an idea, Emily? Nobody knows.
The question, can you, I'm not really getting it. Is it that the variable changes across time?
Yeah, it changes across time, but if there is T, it means that there is also what? T plus what? It means there is T plus 1. And it also means that there is T minus 1. That's what it means. Okay? That's what I wanted to note. If there is T, then there is also something before T, and there is something after T.
Right.
Okay, so that's the time series. Now, let's look at some assumptions of panel regression before we look at the panel model. Okay, and this is very important, guys. Pay attention. This is it. This is the huge thing you got to. Oh, by the way, there's one final assignment on this. That's why it's important to listen. And the first assumption is exogeneity. What does exogeneity mean? What does exogeneity mean? The expected value of the error given the independent variable is equal to 0. That's exogeneity, but watch it. The expected value of the error given the independent variable, given is 0. This is what we knew before. We knew this. But look at this one. The expected value of the error. The previous one was given that the independent variable is fixed, given the independent variable. But this time, the expected value of the independent variable weights, not given, alongside the independent variable. The expected value of the error is also 0. What does this mean? What does this mean? Who can tell me? What does this mean? Come on. What does this mean? Exogeneity. How is that different from endogeneity? Of course, we're going to talk about endogeneity. But how is that different from endogeneity? Let me go to somebody who hardly talks here. David. David, tell us. So exogeneity is something that is not related to the model. Okay? Something, if you have a variable and that variable is exogenous, okay, it means that the variable is not correlated or is orthogonal with the error term in the regression. It is not correlated with the error term. That's what we mean by it's exogenous. But if it is correlated with the error term, then it's no longer exogenous. So without exogeneity, then you have endogeneity. So one thing about exogenous variable, okay, or a particular independent variable, because this is all about the independent variables, take note. The independent variables are the right-hand side variable. Okay. And some of them could be exogenous, some of them could be endogenous. Okay. When there is a change in that exogenous variable, those changes are independent of the other factors. So let's take a variable like experience. We all believe that experience can affect your salary. The level of your experience will determine the level of your salary. However, if experience itself is able to better define your salary only if there is education. So if your education is higher, then your experience becomes more visible before the experience will affect. So in this case, education alone, experience alone is not working. It is relying on something. It's multicollinear with another variable before it can work. That is what we call multicollinearity. But when it is not another independent variable, but it is rather the error, then it means that that variable, that independent variable, is no longer exogenous, but it's endogenous. So it allows, the variable to be having that causal inference, very clear. So take note, a variable is endogenous if it is correlated with the error term in the regression. But if it is not correlated at all with the error term in the regression, then it is endogenous. Endogeneity is not good. It can lead to biasness, inconsistent estimate, making problematic for causal inferences. Now, what we are assuming in a cross-sectional work is that we have weak exogeneity. So there is exogeneity that is very weak. Okay. We'll look more at this. The next assumption is homoscedasticity. We know this already. The variance is supposed to be homoscedastic. In other words, the variance is supposed to be constant over time. We've looked at homoscedasticity many times, and heteroscedasticity is the opposite. And this is about the errors. Take note, most of these things are about the errors. The next assumption is no serial correlation or no autocorrelation. In other words, the covariance between two errors, error ui and error uj, their covariation between them should be 0. In other words, there must be orthogonality. The two must be orthogonal. They must not be correlated with each other. If there is no autocorrelation, if there is no serial correlation, that is, if there is autocorrelation, then the beta parameters are going to be not blue. Okay? They are not going to be blue at all. And that is not good. We've already spoken about endogeneity, independence between the errors and then the independent variable. There must be 0 correlation between them. And then, of course, then perfect multicollinearity. All of these assumptions are assumptions that we know in basic, regression. When there is, we've looked at these things, when there is heteroscedasticity and autocorrelation, what do? You use the GLS, or that is, GLS is a new model, okay? Or you use the weighted least squares, which is called a feasible GLS. However, you can still go ahead and use the further OLS and still run your work and correct for the heteroscedasticity and autocorrelation using what? Who can remind us? You correct that using what? You still run your regression, but you correct that using what? You use the newer West standard errors. Okay, that's heteroscedastic autocorrelated consistent standard error. That is what you will use to correct for possible hetero-auto in the work. Okay, so this is a panel model. The panel model is the final one that combines everything we have mentioned. What makes this a panel model? It has an individual specific effect, I. It has a time specific effect, T. It has a constant and an error, and it has a coefficient, a transpose of the coefficient actually, multiplying the independent. Now, the thing about the panel model is that the error, which is the UIT, that error is composed error. Take note. It's not single error. is composed of many things. And that is the essence of the panel. That's the battle. This is where the battle is. Let's take a typical example. Suppose you want to measure the performance of firms, which you call efficiency, theta. That theta is equal to ZIT. Theta is changing across individuals and across time, and is affected by Z variables. And these Z variables are called the independent variables. So you would have estimated the theta on the left. And then you will add the errors to it. You can see that the errors have got different things attached to them. So this is a typical example of a model. In this model, we know what the I is. Look at it here. We know what the I is. We know what the T is. And we know that what the IT means. The dependent variable is YIT. The independent variable is XIT. Okay. Please note that the parameters are also called estimators or the coefficients. What does the X mean? The X are the regressors, the independent variables. There are several of them. These environmental, or sometimes called even explanatory variables, are the variables of interest. But when you are doing your thesis, guys, you will notice that sometimes you have to focus on one or two of these variables. Don't focus on all of them. Okay. And remember that the XIT does not include the constant. The constant is separate. The next variable in the model is the error. We check it carefully. Okay. After this, the next one is the error, the composed error. Please remember that one of the error, the first item there, is not the composed error. It's not. It is the what we call the individual specific factor. Whereas this one is the lambda is a time specific factor. We'll come back to them. Okay. So if you watch carefully, the UIT is made up of 3 elements. The last one, the epsilon, is the stochastic noise. It is independently and identically distributed with a 0 mean and then a constant variance. It is a new error component. So watch this. So this one is a composed error, and this composed error includes the stochastic noise. And this composed error is composed because it's made up of 3 things. You can apply exogeneity to this composed error. You can assume strict exogeneity. But then the independent variables can be 3 different ones, actually. You can have some of the independent variables or some of the regressors which are varying. Varying regressors are those independent variables that are changing. They are not static, they are dynamic. A typical example is your income. Your income is rising and falling every time, rising and falling every time. Then you have another group of regressors called time invariant. They are fixed. Time invariant means they are fixed. At least within a year, they are fixed. Like gender, like race, like education, they are fixed. Now, why is education fixed? Education is fixed because sometimes the belief is that once you have finished school and you are working, you don't really want to go to school yet. So for that period, education can now be said to be fixed. Then you can have time. So remember, we have time invariant, which means these variables are fixed over time. And then we also have individual invariant, which means they are fixed across individuals. Let's take an example of individual ones. For example, when you take the GDP of a country, it is fixed for each person. If it is high, each person will get it. If it is low, each person will get it. So it is the same for everyone. So it's not changing across individuals. It's changing across industries, across countries. That's okay. But when it comes to individuals, it is fixed. So those are the three groups of independent variables. Now, that leaves us with the UI. The UI is an unobserved factor. The unobserved specific effect. Okay, it's sometimes called unobserved heterogeneity. It's a very nuisance thing. Okay? It doesn't have time because it's fixed over time. It has individual because it's changing over individuals. Okay. What does it do? It captures the characteristics that are not picked by the independent variables, and it includes a special ability. So somebody is getting a lot of salary increase, not because of necessarily of his position, but it's more because of the person's special skills, his ability, his culture, his behavior. For example, there are some people with certain culture, they are known to be athletic, very athletic. Which country? When we talk about athleticism, which two countries can you think about the moment we talk about athleticism?
Kenya.
Kenya. Which other one?
Jamaica.
Jamaica. So you see, they have that thing, that special ability in there. That is what we are discussing. Now, this individual factor can be dynamic or it can be fixed. Okay. Special abilities can be dynamic, male and female. Pregnancy is never going to be two. It's going to be for one particular female. Okay. So you got to know the times in the panel. And then finally, the time specific. They are the same as the macroeconomic factors. And they to themselves, they want to be around. The lambda t is composed of several things. And lambda 1 d2 t is, it wants to be around t. It wants to be around t. It's like it wants to be around this lambda t, and that's what it does there. The final one is the error, the normal noise. Okay, you can impose other assumptions like parameters, exogeneity of the regressors. You can bring about the errors of the so many things. Okay, let's take a typical example of a panel data model. So if you look at PI is the productivity index. And the productivity of a firm, this is an insurance firm. The productivity of an insurance firm is affected by whether it's a life or non-life, the credit risks, the leverage, the log of the total asset, the log of GDP, the log of total asset, GDP, inflation, pure technical efficiency, skill efficiency, regulation. Now, what we got to do is to determine whether it is I, individual specific factor, or it is T, time specific factor. You get it wrong, you're out. You get minus correct. So let's take life. Is it life? Is it dynamic? No, is it an individual specific factor or it is a time specific factor? What do you say? You can tell us. Is it an individual specific factor or time? Life is a dummy, so it's individual specific factor. Credit risk is time. Leverage, time. Log of total asset, time. Log of GDP is time. But you see, all of the first 5, they are all both time and individuals, time and individuals, time and individuals. But if you look at GDP, it's only changing across time. It's only changing across time, but it's not changing across individuals. So that is it. Inflation is the same as GDP. Regulation is changing across time. So that is how you have a specific situation. Okay. What I'm going to do is I'm going to, yes, Emmanuel.
Doc, thank you very much. Please, your last slide, but explain whether it is changing by time or by individual factor. Looking at the first variable and GDP, what is the differentiating factor that makes it varying with them? And you mentioned that the credit rate is also changing with time. So what makes the first variable and the second variable different in their individual specific factor, please?
Okay, so to be honest, the first variable, I said it, that it shouldn't have been IT, it should have been I, just I.
Okay, so per the current description, there's an error there.
Yeah, because life, that life is whether you are life insurance or you are non-life.
Non-life, yes. And
And that is changing across individual.
Good. There shouldn't be the T there.
Correct.
Okay, then with that one, I understand. Yes. Okay, so I now understand why the life is changing with individual factor and why the credit risk is changing with both the individual and the time, and why the GDP is only changing with time. Thank you very much. I'm grateful.
Do you understand that of the regulation?
Yes, I do. Yeah. For example, the regulator may bring a different measurement and regulatory factor with respect to time. And
Yes.
as time changes, they may enhance the regulatory requirement for compliance purposes. Therefore, I agree with the model as it has been explicit in its current form. Thank you very much.
Good. And you can see also that in terms of regulation, the government can increase the minimum capital requirement.
Very.
At a particular point in time. So that only changes over time.
It's true.
Let me tell you, when you're doing your research, one of your battle you're going to have is you're going to guess variables, and your job is to come out with whether it is I or IT or both. That's it.
Okay, sir.
And with assignment, I'll give you.
What does this represent? It represents what variables? As you explained in the previous
time
ones,
dummies.
That means good. Okay, thank you very much. Okay.
Time dummies. So you can represent all the time and say that the time is also changing. So in this case, you are checking whether the dependent variable itself, without even being affected by the independent variables, is it itself changing over time?
Okay.
For example, if your dependent variable is the performance of your economy, is that performance itself, is it changing over time?
Okay.
And that time dummies, that lambda will tell you.
Okay.
All right. Now let's go to the wage band data. Who has opened the wage band data? I'll put it in the group for you, please. I want you to open the wage band data because the essence of it all is to make sense of it all. The essence of it is to make sense of it.
Please, we've opened it. I have opened it, sir.
Okay. Please let me see by hands, those of you who have opened it. Please don't raise your hand if you have not opened, because I might ask you to do something. Obedajiri, can you share your screen? Let me see. Obed.
Yeah, hello, Doc.
Okay, can you go ahead?
Yeah, please. And the laptop I'm using is not. I've not used a laptop to join the meeting.
I was just hoping that you will not come out and excuse. Jared, share your screen. Obed, take a screenshot of your destiny and send it to me.
Okay, thank you.
You see how he's sharing it? This is what we call honesty. Beautiful honesty. Now, this is why I give marks to people who are truly students, ready to study. I've taken a picture already, so the rest don't show anything. Now let's go to Nanabuama. Show me your screen. If you don't have it, I told you not to. Just show. Very good. So Nana, can you walk? Oh, show it. Show the screen. Good. So walk us through each column and let's see.
Sure. So we have, the IDs shown over here, and then through to the years, age, experience, union, married, ethnicity, disability, rural, region, wages, sector, occupation, education. Yeah, so education, occupation.
Where's the last one?
So the last one is D87.
Yeah, what's that?
So they are, I think, binaries. 0 and then ones.
Yeah, but what actually is that? What do you think that is? Kingsley, what do you think that is? Those last few.
Doc.
Kingsley.
Hello, Doc. Yes, Doc.
Right.
The D81, D82, D83. I think they are categorical variables.
Of what?
I'm not too sure of.
You are being polite.
Yes.
You are failing. Albert, what is that? The last color, what are they, Albert?
I think they are, they are binary variables, like yes and no. Yes, 1 is for yes, 0 is for no. Yeah, and I think.
Yeah, but what does that mean? What does a column heading mean?
The column heading, it could be years, like D81, 82, 83, 84, 85, 86, 87.
Did you say it could be? Did you say it could be?
Yes, Doc.
Okay, it is.
Okay. Doc, is it dummy 81?
Exactly.
Dummy 83,
Okay.
dummy 84.
Exactly. So you see, based on your answers, we are able to know those who can teach the students one day. Yeah. So these are dummies. They are time dummies. You can code them yourself because if you look at the first one, okay, the first one is the year 1980. and that is 0. But 1981 is 1. So take note of the way this data really looks like. Okay. Now, let's try and get a feel of this entire data. So let me share the screen for you to look at it. So this is this data set. And when you look at the slides, we call it the wage pan. Please lower your hand. What is the wage pan? You can put the data in the long form. That's all we have it there, in the long form. We are going to do some research, and this research is what is calling for this data. So let's give our title to our research. Whose this thing is disturbing like? Nobody. All right. So this research, that is how it is. Now, I want you to look at this data set and think about what topic would you have given to it. Who can do that? Yeah, who can tell me? If you were to think about a topic, what topic could come into your mind? On based on what? This is called deductive reasoning. Yes, Watson.
So, the topic I can think of is something like the determinants of wages.
Good. That's it. That's true. The determinants of wages. Factors that influence wages. And in fact, what is so interesting, guys, is that that is similar to the title we're going to have in mind. This is a title that was selected by one professor. Whose wages do unions raise? You see, even though you are picking at the determinants of wages, he had a particular item in mind. And if you have checked econometric papers, that's what they do. There are other several factors, but their focus is on one particular item that you want to examine. Emily, in our paper, in the corporate philanthropy paper, what is the key factor that you are looking at with a dependent variable?
Yeah, I think the key factor will be the FTR.
People don't know FTR, so when you say FTR, I haven't spoken.
Okay, future time reference.
Yeah. Okay, so the future time reference is the main variable. Now, Hassan, in your case, which one is the main variable here? Looking at what you see.
Yeah, it's the wages.
Yeah, the wage is a dependent variable. Which one is the main independent variable?
Okay. Let me see.
If you want me to show you the, but
no, I wanted to look through the title to determine
I thought you have looked through I'm showing you.
No, I was analyzing something.
There you have
okay. It is the unions. If there's any variable called union in the data, then it has to do with the union.
It is. It is a union. And when you look at the column, one of the column, which is known as F, column F, you will notice that the variable there is what? Union. So what do all these variables mean? So first of all, whose wages do unions raise? It's a very deep question. This is dynamic model of unionism and wage rate determination for young men. Very, very important work. Whose wages do unions rate? You know, union is when you belong to a union, labor union, a particular union in the workplace. And you know that if you are in the union and the union are fighting for their members, you'll be supported, right? So whose wages do union raise? Do they raise their own wages or even the wages of those who are not part? That is this was a paper that was written by Vella and Verbeek. In 1999, they were analyzing this data that you are seeing under Excel. And the data is from the National Longitudinal Survey. It's a data from 1980 to 1987. It's made up of 547 full-time working youth males. So to what extent would you realize that the data is biased, a bit biased? You can tell me. Under what circumstance do you see that the data is a bit biased? Yeah, somewhat.
I think the mention of youth sample, so it's biases it towards the youth.
Okay, that's one. What else? Francis.
Look, the data is gender bias. So it looks at only males and not females.
Correct. That is true. So there's that sort of biasness in the data. But there's something more. Oh, there are more hands, eh? Madam.
Hello, Doc, I forgot to lower it.
Please lower your hand. You're not looking for forgetting people. Samson.
Yes, sir. So talking about full time, I think people could be part of unions even though they might work part time. So by going strictly with full time, that could be a bias.
Good. I needed that. Full time against part timers. That's it. Of course, there are other things. So this is your data set. It's a balanced data set. Balanced. 8 years of data for each of the 544. So how many observations are there? How many observations? Given that it's balanced. How many observations? You got to be incredibly smart to give me the number. How many observations? Oh, this one you should be able to tell. 545 samples. How many observations?
It's 4,360.
How did you get it?
You multiply it by 545.
Exactly. Somebody is sitting down. The person was wondering. What is the time period? 8 years. Is 1980 part of the years?
Yes, it's part of it. Before you can get the 8, then it should be part.
Good. And these are youth. They've just completed school. By 1980, all of them have completed school. So you can now understand why we made education fixed. Because from the period under study, none of them is supposed to be going to school because they just completed school. They need some cash in their pocket. And that is why education will be fixed in this data as we go. It will not be time varying. Education will be time constant or time invariant. Okay. Now, the sample are made up of young children. Age in 1980 are ranging between 17 years to 23 years. Those are them. And they've just entered the labor market. They have an average years of experience, 3 years at the beginning of the sample. So by 1980, the average experience is 3 years. Take note of that. Very important. These are the information needed for the data. You have ID. ID is an individual. The NR, okay, is the year times the age. Experience is EXPR. Okay? So that's experience. The union, so by the way, note that the experience is computed as age, the age of the child minus the 6 years of schooling. Okay. The age of the child minus 6 minus the schooling. Then you have the union. The wage is normally set by collective bargaining. So the union here is a dummy variable, which is 1 if the person belongs to a union, or 0 otherwise. 0 otherwise. This whole of this will be part of your data. The next one is married. By the time the person starts work at the age of, in the year 1980, if the person is married, it's a dummy variable of yes. If the person is not married, it's a dummy variable of no. Ethnicity. There are quite several kinds of ethnicity. We have Black, we have Hispanic, we have other. Okay. And when you look at the data set, let's just go to the data set. You can see that it is showing other. Now, if you want to filter, if you go here in the Excel and choose filter, the filter will help you. Once you click on this, you will know the different kinds of, the different kinds of ethnicity in there, which is really cool. Now, if you are looking for married, you will know that the levels are just 2. If you are looking for disability, you will notice that the levels are just 2. But if you're looking for sector, okay, you see the number of levels for sector. So many sectors. And of course, if you're also looking for occupation, okay, the number of occupation are plenty. This is examinable. All right, so keep that in mind. You can have disability as option, yes or no. You can have several of the variables. You can have whether the person is living in a rural area or in an urban area. Whether the region of the person is north, east, northern, central, south, and other things. So if you go to the data here, and it's always good to feel your data. So if you look at region, you have northeast, northern, central, other, and then cross, and the south. So you have them all explained. And then the sectors, you have them. The wage is the hourly wage in US dollars. Occupation, we've already mentioned that they are all dummies. Education is the years of schooling of the person. That is all here. And then the log of the wage is a natural log of wage. You see, Emily, if you check carefully, we had only one dependent variable, which is wage. And it is only that one we have taken the log. So you can take the log of just the dependent variable and interpret everything in percentage. Guys, pay attention here, because most of the papers I've given you are not doing this. And you have to use what we are discussing here to punish those papers. Punished them. Mine is packed. Punish mine too. Oh, you've not seen mine? Is there? Every regression we are going to do will have that year time dummies. So Emily, this is the one that Eric will indicate that they are being controlled for. So you control for all the time dummies. If they are there, they should be controlled for. Now, here are the research questions that this paper intends to answer. Question 1. Has the return to education changed over time? Look at the question carefully, guys. So you see, you are not just doing econometrics, so you are combining your knowledge with what you are doing. Has the return to education, what is that return to education? What is that?
I think that should be the wages.
Exactly. You see the way it's written. Instead of saying that has wage changed over time, rather said has return to education changed over time. Very, very intelligent way of formulating your research questions. 2, what is the effect of unions on wages? And I know that is the main work, isn't it? So your literature must gather a lot of people who have tried to look at this thing and have failed. Okay. Then you have what are the key forms of worker heterogeneity generating the indigeneity of union wages. So you will notice that there is so much indigeneity in the union wages. You will understand this when you have actually watched the whole work. What are the key forms of worker heterogeneity among those, indigeneity in the union wage? And finally, with what form of economic sorting behavior in terms of union and non-union employment are the data consistent? So these are some sort of questions that you want to address with your data. But there are some few things you got to take note of. Some variables are changing over time. What are they? These variables are changing over time. Guys, who can tell me under what circumstance can you say that each one of these variables is changing over time? Who can tell me? All of these are called EDA. You are exploring your data. You are making sense of your data. If it is your thesis, you will have to go and collect the data yourself before you make sense of it. So who can tell me, under what circumstances are these variables changing over time? Pick one. Which one?
So, for instance, with marital status, someone could get divorced along the line. So it means that if you are married, your status could change after some time.
To what?
To divorced or to separated.
Oh. Master, there was no mention of divorce and separated there. So your status will change to what?
To
single. Huh?
To single.
Exactly. Exactly. So that is why we consider marital status as changing, as dynamic. What about experience? It's obvious. Experience is changing over time, every year. But the way experience is changing in a strange way. Now, last one. Under what circumstance could the union status be changed? Yes, Samson.
I think from the start, maybe an individual may not join a union, but along the time they decide to join, so they could change from where you name it 0 and 1, maybe from 0 to 1, as new member of a union.
Very good, excellent. Richard.
Yes, Doc. I'm thinking about the youth status. Those who are 23 years after the 8 years, they may fall outside the youth.
Remember, everything should be within the 8 years.
Yes, because I'm using the European definition for youth. It's less than 30 years.
Master, this is
Actually,
1989. Anyway,
around
you
eight.
go on
It's
with your
around
point
eight.
and let me see.
Yeah. So that's what I'm saying. That some people may fall outside being youth within the period of the study.
So
that variable will change over time.
that variable could change over time. The union will change over time. They're talking about union now. We are talking
No,
about union.
the union status, some may think that the union is not helping them. In that case, they may decide to opt out of the union.
Yeah, but that's what your colleague said, or is that not what he said?
Yes, please.
Yeah. He said that you join the union, you're not comfortable with it within that 8-year period, you quit. Or another doesn't join the union within that 8-year period. You realize that hey, Master, I need to join the union so that I can get support. So he joins. So union then changes from 0 to 1, 1 to 0, 0 to 1, 1 to 0. That's a possibility. Okay. So take note that these are young people. The thing about experience, I thought one of you would talk about. If they are going to change their experience is changing for everybody, isn't it? You guys know that. Experience is changing deterministically for everyone. For example, let's say that you are 17 years and when you joined the company, I am 23 years. Okay, when I joined the company. Next year, all of us are going to increase our experience by 1 year. Subsequently, we increase another experience by 1 year. Then subsequently, another experience by 1 year. You get a point? So in this case, since we are all increasing our experience by 1 year, it is as though by the 8 years, nobody has increased his experience. Does that make sense? Because it's like we are all affected by the same thing at the same time. So it's like nobody has been affected by anything because we are the same by the time, in terms of time.
Yes. Yes, sir.
It's like being affected by GDP. GDP is affecting all of us. So that's why some people were saying that Nanado shouldn't have complained because COVID hit everyone. So for him to use COVID as a yardstick to indicate why you are broke and poor, that is not how it should define because it affected Togo, it affected Nigeria, it affected US, it affected Canada. So we are all being affected. So you shouldn't say that yours is special. You can't come and tell me that your experience is more than my experience. Unless the experience you brought along. Yes, Richard.
Yes, look. So the experience, are they all doing the same kind of work? If they are not doing the same kind of work, and that these youth are doing different jobs, then
it is how you define experience. Because remember, we indicated that experience is measured by time. Do you remember?
Yes, Doc. So the experience may be nuanced. Once the jobs they are doing are different jobs, so the experiences may be different from others. And if some depending on the job too, the experience they get may affect their salaries. The kind of
the experience they get may affect. But then what about salary you start with?
The wages, yes.
Whatever salary you start with, you are moving with that experience. The key point you got to understand is the experience is being measured by year.
Okay.
Not by the way we remember this is 1980 something. Not by the way we measure experience today. For example, today somebody may have experience in communication skills, another will have experience. So it's not determined by your time in the company, but it's determined by other factors that are skill. So today we talk about experience in terms of skill, being a skilled person.
Okay, thank you.
All right. So those variables are changing. Okay, they are varying. Then we look at variables that are constant. They are not changing. They are constant. And again, you see experience come here, and I'll ask you again why. So the first one is race. They don't change over time. I'm sure as for race, you all agree that race is fixed, at least within a year.
Yes, Doc. We all agree.
Why do you think education is set to be fixed here?
Sir, it is said to be fixed because there was an assumption that at the time of the start of the study, each of the participants had finished school. So we are taking it that they are not in school at the time.
Very good. Very, very good. That's why. Okay, that is exactly the case. Now, what about, and in fact, even though education is fixed, presumably fixed, even if it changes, it is changing the same way for everyone, if they are ever going to be. Okay. But the key point is that education is fixed because of what we said. But even though education is fixed, we can interact education with each year dummy. So we can multiply the educational value by the time and see how the education of the person over time is affecting the dependent variable, which is salary or wage. Okay. Because you see, we know that your education will affect your salary. But since we all have the same educational level, so what you got to do is multiply the education with the time. Okay. Interact the education with time. And when you check it and you look at the time variables, some of the time variables are 1, some of them are 0. Let me give you an example. So when you take time like, let's take time like 1981. So if you look at 1981, it is only 1981 that this particular individual person is having 1. Every other thing is that person is having 0. Every other thing that person is having 0. If you check the next person, and by the one I say person, you can see that I'm talking about person 13. Okay. Person number 13. So this is person number 13. So person number 13, for that 8 years, because we are in 1981 is having a value of 1. Every other year, that is 0. So you can take this education, where's that? You can take the value of education here, column O, this 14 multiplied by 0, that will give you 0. 14 multiplied by 1 will give you 1. 14. 14 multiplied by 0 give you 0. 14 multiplied by 0 give you 0. Like that. And so you are interacting. That's the meaning of interaction. You are interacting that to see how, if you bring time into the picture, does education still affect? Because remember, we said that it's not changing, it's fixed. So now let's make it unfixed. Let's make it like it's changing. But the only way you can make it like it's changing is by multiplying it by the time done. And then you create a new column for education. And then you can see how education over time is affecting the wage. It's a beautiful concept today. That's one. The other variable that is set to be fixed over time is experience. And I think I told you why. Who can remind us of why we believe that experience may be fixed? You said it.
Yes, you said that because every other person is getting experience at the end of the day. If everybody, as I assume, is getting equal amount of experience for the time being, then there is nobody who can experience more than anyone, so it is fixed.
Excellent. That's it. Now, if gender was here, gender would have been fixed as well. But everybody here is a male. So that is why. Now, one more thing. The UI, the individual specific factors, they will capture all the unobserved, time fixed factors that affect the dependent variable. Okay. So all the individual specific factors the fixed factors, the fixed effects. All these fixed effects are fixed over time. So you can see that the race is a fixed effect variable, education is a fixed effect, experience is a fixed effect. They are fixed over time. And we'll explain why. Now, we are going to see that some of the variables are logged. In this context here, which variable was logged? Which variable?
Wage. The wage was logged.
Exactly. Why would you want to log the wage? Who can tell us? Why would you want to take the logarithm, the natural log of the wage? What will
One of the reasons could be because compared to the other variables, they are kind of small because if I remember the issues of union, for example, is 1 and 0, 1 and 0. So wages will be way bigger than any of the variables. So taking the log reduces it a little.
Oh, really is little.
Oh, much more because that is the natural log is to base 10, so it will reduce it much.
Okay, so practically, why would you want to take the log of wage, practically speaking?
Practically, that's taking the log will bring the value of wages down somehow to comparable with the other variables to make it the regression to work in that manner. Otherwise, one side will be very big as against the other side that is very small.
Yeah, you're speaking, but you're not really speaking practically for the ordinary person to understand. Who can help? Francis, are you there? When I call you like that, it means you're smart.
Look, I went off a little. I just reconnected.
Okay, so you don't know what we are discussing?
No.
Samuel, are you there? Okay, so the wage is nominal.
Hello, Doc.
The wage is nominal wage. And nominal wage is affected by inflation.
Hello, Doc.
It's okay, it's okay.
Okay.
Nominal wage is affected by inflation. And because nominal wage is affected by inflation, if you take that money and you go and use it to buy a car, by a year, that money can no longer buy a car. So you got to kind of deflate the money using the deflator, the price deflator. And so why would you take the log? You take the log in order to move the wage from the nominal to the real, because now what you need is not the wages, rather the purchasing power. The purchasing, that's why it's called natural. You need because if somebody gives you 2,000 in the year, and let's say that somebody gives you 10 cedis in 1951 or 57, and then the person gives you 10 cedis here today. Both of them are not the same. Inflation today has destroyed that value. So if you want to give me money, you have to know, if you tell me that 1957, I gave you 10 cedis, and this time, the only equivalent of that 10 cedis is to calculate the deflator and then multiply by the deflator so that you can know the real value that 10 cedis will buy at that time. Then you do the same thing for this time. So maybe this time the person will not need that 10 cedis. He might need 500 cedis. Okay. Or if 10 cedis was equal to 10 pounds at a time, you just multiply those 10 cedis by, let's say, 20 pounds. And that means that you have to give 200 cedis to the person now. That's this equivalent. Okay, guys, I hope you understand. So the logs will convert the changes in the variables into percentages. Okay. So once you take the log, now when you are interpreting the item, you don't say a 1 unit increase in that. Rather say that a 1% change increase in something will lead to that. And this is very important. Okay. This is very, very important. So Emily, for example, Which of the variables were logged in the corporate philanthropy paper? Donation was logged. But which other independent variables were logged? So that's what will give you the idea. So take note, if we use a nominal wage rather than the log, then it's important to rather go and get a real wage. And it's quite difficult to get a real wage because the real wage is what is the purchasing power. And that means you got to go to the market to really understand the real wage. But simply means you are bringing the inflation into the picture. So if you use a nominal wage, which is what we normally always have, then it can lead to serious misleading results. So you got to take the log of the nominal wage to impose that constant percentage effect or to bring about the inflationary trends. That's one reason why. Now, there's another variable here, which is called square. So when you check here, you see the education, you also have education square in column Q. So apart from taking the log of the wage, by the way, when you take the log of the wage, okay, when you take this wage, when you take the what's the wage? This is a wage, column L. If we take the natural log, how do you do that? If I stand here, but even if I go to the left side, and then let's say I create an empty space here, and then I call it the log of wage. And then I decide to go here, do equal to, you take the natural log, okay? If you take the natural, we call it ln. ln, okay? So this gives you the natural. If you double click here, and you select this, and you click enter, bang. The value you are getting here, that is what you see on the right here. That's what you see on the column here for the natural log. So that's it.
Yeah, Doc, I can see your proficiency in Excel. I believe very soon you'll be patching some of them to us so that we can be under your study.
I don't get you.
I have seen your proficiency in the use of Excel. And I believe very soon you will pass some of these skills to us as we finish the hour.
Sure. You don't have a problem. And once you have this calculator, remember you can see it at the top. If you double click, you see the natural log. Okay, so this is the natural log of the value. All you do now is that you go to the right corner here, just double click, and every other thing will populate. That's it. The rest are populating. That's how you take the natural log. Okay, let's undo. And that's what that very one has done. Okay, that's what we've done to get the natural log of all of this. Cool. Now, let's go to why you take the square. So you can see that experience, we said experience was fixed, more or less. So if you look here, experience was fixed. Okay, so we decided to take the square. And you can see that everybody's experience is increasing by 1 year. You can see that. Okay. This person started at a certain age. This person, second person, had 3 years of experience already. So from the time of start to the next year, his experience went to 4 years. Okay. That's how this person's owned it. But this person had no experience at all. So by 1 year, he's got his 1 year experience. By 2 years, he's got that. 2 years, when you square that one, you get 4. By year 3, he's had 3 years of experience. When you square that on the right here, you see that it's 9. And then it goes on and on. Why are you squaring experience, but not that of the others? Here's the thing. You want to handle polynomial. You want to handle the quadratic nature of the data. What do you mean by quadratic nature? You see, one thing about experience or quadratic behavior of items is that they rise, they get to a point, then they start falling. They rise, they get to a point, they start falling. You see, now the thing is looking quadratic. It's no longer linear, but it's non-linear. It's non-linear. And it's curved. It's non-linear. It's polynomial looking. And therefore, you got to capture that. Now, but is that practical? Yes. Why? Let's take something like experience. You know, sometimes for some particular industries, okay, not all industry. I think academia, it has been said that academia, generally experience doesn't fall over time like that. Generally. Because somebody can what do you call it, can retire, and the person can still teach and can still publish, isn't it? But that's not like that with football, isn't it? Football,
yes, football, you can't.
You pension early. You pension very early, and then you experience, you have something we call physical diminishing returns. So there's physical marginal returns to productivity. But you don't easily get mental diminishing returns. Right now, some of you are tired. You're having some modicum of mental diminishing returns. I know. Your brain muscles are, discombobulated, my friend would say. And so it is evident. However, generally speaking, that shouldn't be for situation. But experience in this very example can diminish. The nature of the industry will require that. So when you believe, theoretically, when you believe conceptually, when you believe, okay, sometimes you may have to borrow some knowledge from quantum mechanics or cortex diagram, or the principle of academy of management, or resource management, or human resource management, something. You draw your knowledge from some theory. And then once you're able to establish it, you say that, look, experience will encounter this. So on the basis of that, I'm going to square experience. Another thing that can be squared is size. Suppose you have size, the size of a company, that is the number of companies getting bigger and bigger. It is believed that as a company is getting bigger and bigger and bigger, it gets to a point, there is this diminishing marginal returns. Why?
How do you use to measure the size here, please? Is it their asset turnover?
Total assets.
Thank you very much.
So the company becomes so big, so many people, so many branches, the whole building is theirs. And yet the CEO, in fact, typical example is the government. The government is so big. When you go to ministries, this one is working, this one is working, this one, everybody is employing somebody. And that is why there's a lot of inefficiency. So there's a diminishing marginal returns to production because there's so many people. So bigger does not mean better. That's what it said in companies. So there's this whole literature on mega measures. There's some people think that when you merge, then you can combine your efforts together and then you can do. But sometimes when you merge, there's a problem of monitoring. You cannot even monitor. The CEO will be in the lift with one of the workers and doesn't even know that it's a worker. Nobody is monitoring anybody. Somebody comes, he takes MPP, papers, graphic, News Times, whatever, and the person will be reading. Nobody checks anybody. They're shocking. Anyhow, this one will do, this one will do. This one will do, this one will do. At the end of the day, nobody does. So that's a practical demonstration of size will generate diminishing marginal returns. And I have some videos here for you to check for how to test for linearity. Very, very nice. Now, because of this, if you don't take care, you'll be tempted to be squaring everything. Okay, we have squared experience. If size was there, we square it. But the key point is don't be squaring things. Okay, that's the point. Don't be squaring things. Otherwise, you bring about, spurious regressions. Yes, Sammy.
Doc, from the last statement, don't be squaring things. So here I want to know what is the
criteria.
The criteria.
I'm coming there.
Okay.
So the criteria. So first is to identify the possible nonlinearity. Okay. Use the criteria known as economic theory, and then Gamshin. So first thing, whatever you want to do, if you want to square, back it up with a theory. Support it with others who have done the same, who are authority in the area. So we are taking the square of this because these people took the square of this and they indicated that this and this and this will happen if this one does. So following these two guys or these 7 people, we are also squaring sides. That's how I do it. You have support.
Okay, thank you very much.
Sometimes though, you have to specify a nonlinear model instead of using the linear model and squaring. So you either have to use the natural log of some things and see whether that will improve the OLS regression. But the key point is get support theoretically. So take note of 2 things you can do in a regression. 3 things actually, 3 things. 1, you can take the log of variables. 2, you can square some variables. Okay. And the final one we're going to look at is you can interact some variables. You can interact. You can interact means that you can multiply this variable and that variable. We've done something like that already between education and dummy. We've done that already. So it's a way of interacting. Let's look at that last one for today, interaction. When do you do interaction? When do you include interaction terms? So first of all, you can interact 2 independent variables. If 2 independent variables are affecting the dependent variable in a way that is not additive, okay? In a way where this is not additive. So if you take x1, we normally say beta 1 x1 plus beta 2 x2. Okay. But then you also introduce beta 3 x1 times x2. So what it means is that whatever x1 variable you have here and whatever x2 variable you have there, you will now create a new variable and multiply this one by this one and get a new variable. Finish. Why would you do that? Well, this interaction term or this multiplication is done to capture that non-additivity between the variables. We've always been saying, and you should be careful not to add too many of them. So because you have to multiply, you're multiplying and multiplying and multiplying and practically. Otherwise, you have too many independent variables. So you got to keep the interaction terms that you believe have theoretical reasons, they follow Gamshian, or you have a strong suggested by your descriptive statistics that you should interact them. Interaction should be done when both independent variables are binary. That's really, really good. You can do that when that is so. But you can also do that when one is a binary and the other is continuous, like the education we just did. So one is continuous, the other is dummy. And then when both of them are continuous, all of these are possibilities. Why would you interact them? The reason why you will normally interact them is that you believe that they have some relationship with each other. They have some behavior. For example, if there is that belief that before you get your salary increases, there's multicollinearity between your experience and your education. Because you came to realize that after every 3 years, you are sent to go to further schooling to come to the workplace. And when you come to the workplace, they will increase your salary. So at the end of the day, once you've gone you've had 3 years of experience, then they send you to go and do masters. Then you come back and then they double your salary. The question is, what is leading to the doubling of your salary? Is it the 3 years experience you had or the 2 years masters you had? Well, in this case, you can see that your masters you had is contingent on you, first of all, having 3 years of experience. So the 2 variables are interacting. So you create an interaction term and see how does that interaction term affect the dependent variable. It's a beautiful exercise. Beautiful exercise. Okay, so let's go back to our data set. Next time, what we are going to do is yes, Richard.
Yes, Doc. Before you go, the interaction, can it also be done to test whether the interaction between 2 variables has the independent variables, the effect on the dependent variable, whether it's producing a synergistic effect or a destructive one? Can something
Absolutely.
like that?
Yes. You can check whether their behavior is confounding or supporting.
Okay. Thank you.
Yes. Interaction will tell you a lot of this. Sometimes you don't even know. For example, sometimes you include a variable, the variable is not significant. Then you interact the variable with another one, boom, it becomes significant. Which means that that thing is supporting it. That thing is supporting. You know, anytime that thing comes into the picture. For example, there are some footballers, you might think that they are not good at all. The moment you bring another player, no, then they start scoring goals. Have you seen that thing? That footballer is scoring goals because the other one is supporting him.
Yeah, no, we see that thing.
And then you can also have a situation where the player is not getting support at all. And then he goes to another team. And this team he goes to, they are supporting the guy. The guy will be scoring plenty goals. Interaction. But please know that interaction is not the same as moderating. We'll look at that later. Moderating. And next time we'll look at moderating, and then we'll now bring all together and look at what models can be used to handle panel data. We'll use the same thing, right? We'll look at what models should be used to handle panel data. So ladies and gentlemen, that brings us to the end of the entire Kabudo. Any question, please?